thing is when you're multiplying a number by 1. If you multiply it by 1, what does it do? It stays the same. If you multiply it by a number that's less than 1, what does it do? It gets smaller. If you multiply it by a number that's more than 1, what does it do? It gets bigger. So please put your pencils down and stop writing, because I haven't told you to write anything. So, for example, I'm just going to prove my point, because I know that a couple of you are probably like, but these numbers are really, really big, because some of these, you know, if I know that I have some students that when they look at 989 thousandths, because there are 9s, they assume that the numbers are going to get large because there are 9s in there. So I'm going to prove to you, because there are some students who do not believe me. So I'm going to take 989 thousandths, and I'm going to just multiply it by, I'm not going to multiply it by, well, you know what? I'll multiply it by 1. So my original number, 1. So 1 times this, and I'm going to compare it to 1. So what am I going to get? What happens to my 1? Does my 1 stay the same? No. It got smaller. Is it 1 anymore? No. It became a number that went below the decimal. So 1 is now larger. If I have 989 thousandths and multiply it by 2. 2 times 9 is 18. 2 times 8 is 16 plus 1 is 17. 2 times 9 is 18 plus 1 19. Carry my 1. 1, 2, 3 numbers behind the decimal. 1, 2, 3. I now have 1 and 978 thousandths. What's bigger, 2 or 1 and 978 thousandths? 2. 2. So if I have 2 times 989 thousandths, comparing it to 2, which one's larger? The product of this or that? 2. So 989 thousandths, is that bigger than 1 or less than 1? It's less than 1. It's behind the decimal. It's less than 1. It is not 1. If we put that on that place value chart that I gave you back in first quarter, it's behind the decimal. It's less than 1. No matter what I multiply it, no matter what I multiply it with, my number is going to get smaller. I could multiply it by this number that is as long as this room. That number is going to get smaller. It doesn't matter that it's full of 9s. So what? They're still less than 1. So, if I'm looking at these right here, these numbers that I have, my A, B, and C, and the numbers that I have in this word bank, or this number bank that I have right here, I have 3 and 4/10 times something is equal to 3 and 4/10. Something times 21/100 is greater than 21/100. 8 and 4/100 times something less than 8 and 4/100. So this is my first factor. These are the numbers that I'm comparing. I need to compare this to this. These are the numbers that I'm comparing. Okay, it doesn't matter where they are. You see, I need to keep this equal to this. What number up here would help me keep these equal if I multiply? Caitlin, are you the only person up here? You and Bailey, the only ones who know? What? What number up here would do it? Yeah.
Oh, 1.
Which one up here is 1? 1 with a decimal and a 0 and a 0. 1. That's the only one up here that has 1. So that. It's been an hour. So this one, something times 2100ths, the product needs to be larger than 2100ths. So I'm done with this one. Which one of these would make my product, Kaylin, which one of these would make my product bigger than 2100ths? My initial product would be larger. Aiden.
1 and 21,000.
How do you know?
Because it's larger than 1.
Because it's larger than 1. I've got 1 here and then some extra numbers. It's 1 and then some. It's almost like a mixed fraction. It's 1 with some extra stuff. 1 in front of the decimal with some other stuff. Okay? Yes, no, maybe. You writing anything down? You're just going to sit there. Eight and 400ths times something less than 8 and 400ths. I need to multiply something here to make this smaller than my number. Taylor. 989 thousandths. How do you know? Not just because it's the only one left. How do you know this would make this smaller? Oh my word. How do you know? There's a rule that it will always work. There's something, there's a reason, Bailey.
Because it's smaller than
Because it's smaller than 1. What's in the ones place?
0.
A 0. All your numbers are behind the decimal. All your numbers are behind the decimal. There's a 0 in the ones place. So it's less than 1. There's nothing over here. Everything's behind the decimal. So it's less than 1. So no matter what you do, your number's getting smaller. So it's less than 1. You multiply it, your number's getting smaller. You with me so far?
Yes.
Just like multiplying a fraction. So, sort the following expressions by rewriting them on the table. So, the product is less than the box number. The product is greater than the box number. So an example would be, if you have 13 and 8900ths times 1 and 400. So what they're doing is they're wanting you to compare. Oops, I wrote over it. You would compare, like this number sentence, they want you to compare to the box number. So would this be less than or would it be greater than? So 13 and 89 hundredths times 1 and 4 thousandths. Where would it go? Less than or greater than?
Greater than.
Why?
Because it's more than 1.
Because it's more than 1. Is it a whole lot more than? No, it's just a little bit more than. It's just a little bit because it's just 1 and 4 thousandths. So it's just a smidge more, but it's still more. So this, you're going to write it over here. 13 and 89 hundredths times 1 and 4 thousandths. It needs to go over here. So what you're going to do is you're going to do that for every number sentence. You want to sort them as to whether your product is going to get bigger or smaller compared to what's in the box. You don't have to write what I'm writing in red. I'm just showing you what you're comparing it to. Okay, so this one, 3/10 times 69 thousandths should be over here. Oh wait, I'm sorry, I wasn't looking up. 3/10 times 69 thousandths should be over here because 69 thousandths is less than 1. I was so not looking up. Oops. Okay. 602 times 489 thousandths, because this is also less than 1. It should be over here because, I mean, you don't even have a 1. You've got nothing in the ones place. 72 hundredths, but you're multiplying it by 1 and 24 hundredths. You're comparing this to itself. You're multiplying it by that. So your number is going to get larger. 102 and 3 hundredths times 4 and 15 thousandths. 4 is decidedly larger than 1. 2/10 times 1/10. 1/10 is a good bit less than 1. So you should have 3 things on this side, 3 things on that side. It really was. Okay, so what we're doing here is when we're comparing these numbers to themselves, we're comparing the product, and they're not even asking you to solve it. You should be able to look at your scaling factor to decide whether or not your product will be slightly more, a lot more, slightly less, or a lot less based on your scaling factor. Look at the number that you're using to multiply. 988 thousandths. Now I'm multiplying that by 4. This is the number that I'm comparing. 4 to 4, okay? The number, my scaling factor, 988 thousandths. Now I know that that is not 1. How close is it to 1 on, it comparing to the whole number 1? How close is it? How close is it? Is it pretty close?
Mm-hmm.
So would it be, so then we know that our product is going to be, is it going to get bigger or is it going to get smaller?
Smaller.
So we know it's going to be less than. Is it going to be slightly, which means a little, or is it going to be a lot? So it's going to be slightly less. That's all you have to do. They're not asking you to work it. They're just wanting you to look at your scaling factor and kind of go, oh, well, it's really close to 1 or really far away. And so it's going to be slightly less. Based on what you know about numbers. So this one, I'm comparing 8/10 to 8/10. My scaling factor is this one, 1 and 5/10. So am I going more than or less than?
More.
1 and 5/10. Is my product going to be bigger or smaller?
Bigger.
1 and 5. Sorry, hundredths. Is it more than 1 or less than 1? More than 1. So my product's going to go bigger. Now is it going to be a lot more, or a little more? Because is this way far away from 1? No. So it's just slightly more. This is, I mean, it's not even, it's just 1 and it's like $1.05. Is $1.05 a whole lot more than $1? No, that's just a teeny tiny bit. So it's just going to be slightly more. Not a whole lot more, just a little bit. $1,725, comparing it to 1,725. My scaling factor is 13 thousandths. Now, is that more than or less than 1? Less. I don't even have a 1. So it's less than 1. There's nothing in the ones place. Nothing. There's not even anything in front of it, so I can't even say it's like 10 or 20. So there's nothing in front of that decimal. Now we need to decide, is it going to be slightly less or a lot less? So we need to look and see how far away from 1 is it? Is it way far away or just a little? How far away from $1 is that?
Way far away.
Is it way far away?
Yeah.
Yeah, I mean, that's like a penny and less than a penny. That's like a fraction of a penny. So we're going to say that that is a lot less. So if I took this and I multiplied it, if I took 1,725 and multiplied it by this, my product would be way far away from that. So a lot less. They don't want you to work it. What they want you to do is use what you know about numbers. They don't want you to work it. They want you to use what you know about place value. Can you look at that and tell that that's less than 1? You should be able to look at that and go, okay, that's less than 1. How much less than 1? A good bit. So if I multiply those together, it should be a lot less than that, than my original number. So I want you to do D and E, and then we'll come back and check if you haven't already done it. I'm giving you a second to work it. Okay. So what goes in this blank? Go ahead and tell me.
A lot more.
A lot more. We have 1 and 3 thousandths. You're comparing it to 1 and 3 thousandths. We're multiplying it by 989 and 1,000. That's way more than 1. Way more. So it's going to be a lot more. That's a lot more. It's going from 1 to 989. So on E, what's going in that blank? Just tell me.
Slightly less.
Slightly less. We're going from 2,000s to 2,000s. We're multiplying it by 911 thousandths. It's not too far from 1, so it will be slightly less. See, not hard. I like to think it's not hard. During science class, these guys that I can't read because there's a little marker thing, measured the length of their bean sprouts. Oh, Carson, that's where the marker is. Sprout is 9/10 times the length of Teo's, and Kier's is 1 800 times the length of Teo's. Whose bean sprout is the longest, the shortest, and explain your reasoning. So, Carson's sprout is 9/10 times the length of Teo's. The Kier's is 1 800 times the length of Teo's. Did they give us the length of Teo's?
No.
No. Okay. So if we just think about, if we just make Teo be T, okay, and so it doesn't even really matter what his is. His is just T. And we know that Carson's sprout is 9/10 times the length of his. I mean, we can even just pretend that he has a number. But I mean, a lot of times, someone had asked me yesterday, they're like, why do they have math problems that have letters? And they substitute letters when you don't know what the number is. And then sometimes they go, okay, find out what A is. Sometimes you don't know what the number is. So we're going to do T. We don't know what the number is. And right now, it doesn't really matter. They're not asking you to figure out what it is. So Carson's sprout is 9/10. So this is Carson. And Zakir, I'm hoping I'm pronouncing that right, is, let me put it all in the same order. Whose bean sprout is the longest? Now that it's all written out and we've taken the information, whose is the longest? Now that it's all written out, it's easier to see. Whose is the longest? With it all written out, and you're all looking at the board, and there's nothing on the window, and there's nothing on the wall, there's nothing at the door, there's nothing on the ceiling, there's nothing on the floor. It's all up here. Whose is the longest?
Here.
Right, because they took Teo's, and his is 1 and more. It's like the same size as his, but a little bit longer. It's the same size, but more. That much more. It's slightly larger than. So the longest and so it doesn't even matter if we know what the number is, because it's times 1 with a little bit more. Who's the shortest?
Carson.
Because
It's less.
it's less than 1. Is it a whole lot less than 1? No, it's just slightly shorter. They're all almost the same length. So they have his is a little bit shorter, his is a little bit taller. So the shortest is Carson. Teo's just kind of in the middle. Almost the same as Carson. But I will say, studies show that you never learn math by staring out the window. 11 out of 10 math teachers agree. Staring at the ceiling never teaches you anything. Especially not math. And I just gave you an improper fraction. Ha ha ha, no one said it. It was a joke. 11 out of 10.
That's why I was. Yeah. What?
It was a joke. Because when I'm teaching this stuff and people are going like this, and then later go, I don't understand, I couldn't do my homework because I didn't get it. And I go, you were staring at the window. I'm so very sorry. You're staring at the window. You don't learn it when you're staring at the window. Okay. You never learn it when you're staring at the window. Okay. I love it when we throw letters in there and y'all kind of go, oh, what now? A times B. And it just, the letters represent numbers. Oh,